Greetings and salutations, and thank you for clicking on the video. In this video, we're going to talk about drive partitioning, swap space, and we'll get into file fragmentation at the end of the video. So this video is definitely for more advanced users, but even if you're starting out, hopefully there'll be some good information in here. I was planning on doing a video about partitioning and swap space, and then somebody asked about file fragmentation on the Easy Linux Facebook page. So we're going to put that in here as well, and hopefully it will be an informative video. Anytime that I comment on these subjects, I always get a lot of questions and people express a lot of opinions, which is cool because Linux gives you lots of options when it comes to how you set up your hard disks and how you get your system spread out over whatever storage you have installed in your computer. So let's get started by talking about partitioning schemes. There are many options and each one has its advantages. I have written in my notes here, and let's start out with a couple of examples. The default partitioning scheme traditionally for most Ubuntu type Linux has been to create a large partition at the beginning of the drive which holds the system, all of the data folders, everything, and then it will generate a swap partition that it will put at the end of the drive. In our examples today, we're looking at MBR, but it's really not that different if you're using a modern system with UEFI and GPT for the partitioning scheme, because the only difference there is that with UEFI, there will always be a EFI partition up front, and that is your boot partition. So the basic old way of doing it with MBR, or if you have a system today that doesn't use UEFI and you've turned that off and you're going in legacy mode, if you just install Ubuntu, everything up to 16.10, what it's going to do is it'll create that large partition up front, and it will format it ext4, it'll mount it at root, and then it will create a swap space or swap partition, and it will usually go ahead and put that in a logical partition, because with MBR you only get 4 primary partitions. So therefore you can create a logical partition, and then you can have as many logical drives in there as you want. So that's how they do it. And then a more advanced method, and the one that I have done a lot myself and done for clients over the years, is to use a separate partition for your home folder. And there's a lot of advantages to doing that. First of all, it separates your personal data away from the system. So if you have to reinstall the system, you can leave your home partition unformatted when you do that, and then all of your data will be there. If you need to upgrade, something goes wrong, you need to reinstall, whatever, that's pretty cool. Also, having a separate home partition will allow you to move the swap partition up on the drive and put it between the root partition where the system lives and the home partition where your personal files live. And it makes more sense. If the machine is going to be using swap, then having that placed between the two clusters of data means it'll be right in the middle instead of having to go all the way to the end of the drive if it starts swapping as in the traditional default scheme there. I came up with a scheme that I experimented around with about a week or two ago and been playing with. I did a video about this and talked about it not too long ago. And what I did was I did the traditional separating the root and the home there, and then I added another partition and I formatted that with the XFS file system, and then I mounted it at VM, and that was for virtual machines only. ext4 is pretty much the default file system for most Ubuntu based Linux, Arch Linux. If you just install it, that's what you're going to get. Other distributions have moved on to more advanced systems, faster systems. For instance, if you install OpenSUSE, they will use ButterFS for the root, and then they will give you XFS for the home partition. ButterFS and XFS are, like I said, more advanced systems. They have their advantages. They're faster. ButterFS There's still questions about its stability. There's some problems with ButterFS. XFS is relatively stable and it's been around for a long time. It is really optimal on servers and RAID arrays with large spinning drives and lots of files. That's what it's good at, and it also is very good at large files. It uses a multi-threaded system to access a drive, so it can actually be reading from two parts of a drive at the same time, which tends to speed things up. That was the reason why I tried XFS on the set-aside partition just for virtual machines, and that was to see if it would run any faster. It did, but not by much. There's always a trade-off with that because XFS actually uses more CPU. So in the case of the virtual machines, yeah, the hard drive access was faster on the large disk files, but what happened was that the CPU usage went up. So it was kind of half dozen of one, six of the other, and it would actually slow down the machine a little bit. So yeah, XFS is cool. At this point in time, it probably would not be a great idea to use XFS as a boot partition with MBR, simply because XFS, unlike ext4, is not automatically checked at boot time. With ext4, the kernel actually runs a program called fsck just to make sure everything's okay and the file system checks out at boot time. Does a real quick check to make sure that everything's okay. Then it mounts the file system and then it starts reading and writing to it. Whereas with XFS, if you want to do those things, you have to install separate tools and then you have to know how to use them. So the only way to actually check an XFS drive is to have it unmounted. Now if it's a data drive, that's no big deal. Just unmount it and run the XFS repair tool, you're good to go. But if XFS is on your root partition, then you're going to have to boot the machine from like a DVD or a USB, and then you're going to have to do it from there. It's a bit of a pain. And the other thing about XFS is it is not as robust as ext4. It doesn't like crashes. It doesn't like the system to halt without unmounting XFS, and sometimes that can cause lots of errors. Whereas ext4, at this point in time, it is very robust. You may get an error or two if the system crashes, but the FSCK program will fix that at boot time. Most of the time, you will never have an issue with ext4. ext4 is also simpler as far as how it accesses the system. It's not multi-threaded, makes it a little bit slower, of course, but it's extremely stable and very steady. So which one you use is up to you. But anyway, in my case, I gave it a shot and it really wasn't worth all the effort. So I ended up going to a different partitioning scheme. So let us look at some of my machines on the network here, and I'll talk about the different partitioning schemes that I'm using and why they are here. My thoughts on this have evolved quite a bit through the years. I don't want that full screen, thank you. My thoughts on this have evolved quite a bit. So the first machine we're going to look at is my HP laptop that's been kind of converted into a desktop, and mainly Cindy uses that machine. So to figure out the partitioning scheme of any computer, just use LSBlock. So you'll see on this system it's really simple. We have one large partition that has the root in it, and then we have at the end of the drive we have a swap partition, and that swap partition is just a little bit bigger than the physical memory in the machine. This machine has a spinning 5200 RPM 320 gigabyte drive in it. That drive is about half full. And if you take your system and you split off all your partitions when you're dealing with one drive, you sometimes can run into a situation where it's not a very efficient use of space. You end up with two smaller partitions and you can't fit all the data you want to in any individual partition, and you kind of wish, okay, I wish I could get some of the data from over on the other partition. ZFS is really cool. That is a really new advanced system that's coming into Linux now and very popular with BSD and Unix. that system actually just creates pools, and it can steal from other pools, which is pretty awesome. It'll do snapshots and other stuff as well. It's not quite ready for the average Linux desktop or laptop yet, but it's on its way, so it's pretty cool. But if you set these partitions where they're pretty much in stone, then you don't get efficient use of the space. Also, this machine it's not really working that hard, okay? What she does with the machine is she does a lot of internet, she does a lot of email, she might play a little bit of music here and there. That's about it. That's all this machine is doing. So having everything separated and all that stuff, it's not that big of a deal. I've got really good backups, so therefore I'm not really worried about keeping the home partition separate. I probably will not be upgrading this machine at any time. If I have to reinstall, I can just rebuild the whole thing. So that's why this is done the way it is done. So let's look at another machine. And this one is a laptop. And this is the one that is kind of like the family computer that everybody goes to. All right. And for a hard drive, this machine has a hybrid drive. It's an SSHD, which means that there's a spinning drive, but there's also a cache, huge cache in the drive, which is like 8 gigabytes. So the drive tries to remember stuff that people access all the time, and it throws it in the solid state portion, and will access that before accessing the spinning drive. And on this machine, there's a lot of accounts. There's actually 5 user accounts created here. So in this case, it was actually probably a good idea to separate that home partition, because rebuilding all of those accounts, even with a good backup, is going to take time. You're going to have to go through and reset everything that needs to be reset and all that stuff. Whereas if something does go wrong with the operating system on this machine, then all I got to do is reinstall the operating system, recreate the user accounts, and all the settings and everything remain the same. That's assuming that the hard drive itself doesn't crash. If the hard drive dies, well, you got to start from scratch, and that's just sort of the way it is. But this is the scheme the advanced scheme that I've pretty much told people who had the savvy to be able to set this up to do for years. At one point in time, I was talking about using a boot partition, even on the MBR partitioning scheme. I've had that in a couple of videos, but since then I have changed my mind on it. I don't really care about boot partitions anymore on the old MBR. And of course, with UEFI and having an EFI partition on there that contains the bootloader, you don't have to worry about that. It takes care of itself as long as that's set up properly. So I told you that I had been experimenting with different partitions at the beginning of the video. So what partitioning scheme do I have running on this machine that I'm doing the video on, which is the one I did all the experiments? Well, I'll show you, and you will probably be a little surprised. That's it, gang. One partition. That's it. One great big 1 terabyte drive, one great big partition. And by the way, all my machines at this point in time, they all have spinning drives. We're not talking about SSDs at this point. We're talking about good old spindle-driven hard drives with mechanics and stuff in them. And this drive is a Caviar Black, 1 terabyte, 7,200 RPM. And so I wanted to see, one of the reasons I was doing all these different things was just to see what would make it go faster. I mean, I've got virtual machines, I've got little files, I've got my whole system on here. And the reason why I went to this was because if we go down here and we do the same thing with this Ubuntu 16.04 virtual machine, you're going to see that they have kind of the same deal as the default. This is actually the default. So what you get here is that you have the partition scheme there that we talked about in the beginning of the video, with one big partition for the system, and then we have ext2 is a logical partition, and then ext5 is the first logical drive. So that's what that looks like. It just looked a little different, and it kind of confused me a little bit there. So if we jump over here and we look at Ubuntu 17.04, which is actually in beta and will be coming out very soon, and I'm running it to take a look at it, you're going to see that now what Ubuntu does is they have one great big partition. That's it. See? That's all. And the reason why is because Ubuntu has decided that they are no longer going to create a separate swap partition on the drive, and they will be using swap files. So therefore, I decided that I was going to give that a shot, even though I'm not running Ubuntu 17.04 on this machine. And I found out something kind of interesting. After all of those different partition schemes, this one seems to be the zippiest. I'm using ext4 for the file system, so I'm not using XFS. And everything is in one partition. I don't care. I do really good backups, so I don't feel the need to separate my data away from the system. I wanted to see how this worked anyway, because this is the new default scheme for Ubuntu. Arch Linux has been using this as a default for a while. Guess what, gang? Keeping it simple makes it faster, even with ext4, which is slower than other file systems. So that's what I came up with. So what should you do when you're partitioning your system? I'll tell you what. If you're new to Linux and you're just starting out, then what I would tell you is just let the dang installer partition the drive. And I'm assuming here that you are not going to try and dual boot, and you don't have an extra data partition you're trying to get around. You just don't care. You've got a hard drive in a computer, and you just want to format it and get it going. That's probably the easiest way to do it, is just to let it partition itself. If you have more than one drive, if you want to separate your home partition for whatever reason, if you want to do some funky things there, then do whatever you want to. But now, with most clients these days, I don't even bother going through setting up a separate home partition and all that stuff. I just say, erase and install. So that's where I'm at on that today. Let's move on to the next part of what I wanted to talk about here, and that is I wanted to talk a bit about swap space, because anytime I mention swap space, I get all kinds of comments about it. And also wanted to talk about swap files versus swap partitions. Swap space provides memory for the kernel to use at times when physical RAM is running out, which means that, let's say that you have a low resource machine, it's only got like 1 gig of RAM in it. You can set aside swap space on your hard drive, and let's say you gave it 3 gigabytes of swap space. You could run that machine pretty hard, and what the kernel will do is, as it's getting to a place where it doesn't have new physical RAM to stick data into, it can actually swap that out to the hard drive, and it does it in pages. That's why in the Windows system you'll hear about a page file. It's exactly the same thing. All operating systems have some way of taking advantage of virtual memory. That's using much slower block storage, which would be a hard drive, in place of memory. And what the kernel tries to do is it tries to figure out what is the most active right now. So it may have stuff that's stored in memory that the user is not actively using. So it goes, okay, I can page that out, and then it puts it over on the drive in virtual memory, and if it needs it back, it can go get it. Back in the days when memory was expensive, and it was very typical to be on a machine that, if you were really lucky, it would have half a gigabyte, like 512. Swap space was really important. My brother had an old machine that we installed Linux on, and it only had 512 megabytes of memory in it, but he was actually able to do a lot because of swapping. The machine was slow, and if he pushed it too hard, he would get to a place where this thing called thrashing would happen. And thrashing is when the kernel has swapped too much stuff out to the hard drive, and it's having to read and write to it very quickly to try and access the memory that is on that drive. So when you get to that stage, that's when you need to go buy more physical RAM. So even today, when we have computers, it's nothing for a machine to have 8 gigs. That's almost introductory. A lot of machines have 16, 32. You can get 64. I don't know where the limit is on memory. You can have as much as you want. It's dirt cheap these days, and the motherboard manufacturers are making it easy to really stuff them. So do you need swap space on a machine like that? Well, some programs use swap space independently of the kernel. They actually will access that part of the system for whatever reason that they're using it. And so therefore, it's kind of nice to have it around, because if you have a program that wants to do that running, then and you don't create some sort of swap space for the system, it may run into a problem. It may become very unstable. Swap is also used to dump the contents of RAM, and I only have RM there. I'll fix that when I post it on YouTube. When there is a crash. So if the system has a hard crash, it'll take everything in the memory and throw it in swap. And if you are one of the 6 people on the planet who know how to read a swap file or a swap partition and extract what information that is, you may be able to debug it. Maybe. There also must be a separate swap partition in Linux that is slightly larger than the total RAM space in order to use hibernation. Hibernation is when you can shut down the machine but save its state. So what the system does is it takes everything that's currently in memory and it dumps it into the swap area, and then when the machine boots up next time, instead of reloading the system fresh, it actually reads from that swap space and then it restores it to exactly where it was. Hibernation is problematic on a lot of machines, and a lot of systems these days don't even offer it as an option. So therefore, if you don't need to hibernate, then you don't need swap space that's the size of the memory. And if you're not really worried about reading dumps when the system crashes because you don't know how to do that, then you don't need swap space that's the size of the memory. An old rule of thumb was that swap space should be twice the size of your memory. Well, yeah, back when we had 512, that made perfect sense. Even if you had a gigabyte, that made perfect sense. Nowadays, it doesn't make sense at all, because if you have more than 8 gigabytes of memory on the computer, chances are you ain't never going to use swap space. And if you do, you're running that machine really, really, really hard. You have a lot of programs open. If you're a gamer, if you work with virtual machines, if you edit video and audio on your computer, then you might actually run out of memory with 8 gigs. You could get close. What happens if the machine runs out of memory? The kernel stops. It just stops. Everything freezes. So that is why you really need to have a little bit of swap space available, even if you've got scads of memory. And these days, a good option for doing that is creating a swap file. So the system in Linux can either take a partition on a disk and it can make that a swap space. And then what it can do after that is that's where the virtual memory lives. And if you had a situation where you were booting more than one Linux system, you don't need to create separate swap space for all of those different systems that might be living on that computer. You can have one swap area and you can point all of those systems to that area when they boot. So that's kind of cool. But if you're going to have one system, having a partition these days really isn't necessary. You can use a swap file. And this is what Windows has done traditionally for years. And some people will go, well, I thought it was cool that Linux had a swap partition, man. It was really nice. Windows uses page files, and I don't really like that. It makes absolutely, positively no difference to the kernel where the virtual memory is. None. Has no effect on performance. I have read that in I don't know how many different places now, and pretty much all the system engineers that work on this sort of thing say, A, you do need a little bit of swap space, and B, it doesn't matter where it is. Could be in a partition, could be in a file. So Ubuntu and Arch Linux now offer to create those swap files for you. You can create a swap file yourself on your system by following these commands. It's really quite simple. The first thing you will need to do is create a file and dump a bunch of zeros into it. You'll use the dd command to do that. And then the next thing that you will do is make that file swap. In other words, you're going to tell the system, turn this into a swap file system, and it'll go do it. And then the next thing that you want to do is to turn that on to make sure it works, and the command to do that is swap on. All of this needs to be done as root to make that happen. Once you create a swap file, you will then probably want the machine to use it at boot time. And to do that, all you do is add this line to your FS tab, which is a file that lives in the etc directory that is the file system table, and it tells the system where all of the partitions on your drive are. So if you stick this line at the end, and you, in this case I'm using swap file name as an example, you're probably going to name it just plain old swap file. Works just fine. You could call it anything you wanted it to. Just as long as the system knows where it is and what its name is, you can use this line of code here to actually mount it at startup. So if you created a system that doesn't have any swap space, and you have just saw my video, and now you're all paranoid because you're like, oh, I need swap space. I've got to have it. I didn't know. I thought I had 32 gigs of RAM. This has been a little unstable. Maybe this will help. Here's how you can fix that right there. At install with any Linux system, you can just do a manual partition and then not include the swap area. Ubuntu will complain, older versions will, like 16.04. It'll complain and go, why aren't you putting in swap space? We need swap space. But then once you get the system up, you can go through this process here and you can create a swap file of any size that you want to, and then the system will be fine. And so therefore, that's what I got to say. This seems to be the trend now, is to not have those separate partitions, but just to have a file. We're heading in that direction. Doesn't matter to me. I've done it on this system. It works just fine. I have been playing around with Ubuntu 17.04 where they set that up by default, and it works just fine. I got no problem with it at all. Now, one of the things that people will go, well, I had one guy say when I was talking about this in a past video is that it causes file system fragmentation. No, it doesn't. It doesn't matter. The swap file in Windows, yes, it would, because the swap files in Windows were dynamic, and they could grow and shrink, and they would cut themselves. That was really not that great of a system with the old page file syst. They called it, that's what the swap file in Windows is called, pagefile.sys. And those files, they had it where it could grow and shrink, and I think you can do that as well in Linux, but in this day and age, you don't even need to worry about that. Just give it like 2 gigabytes worth and go on with your life. No big deal. We don't need to go into all that hassle. So once you create the file on your system, it's going to be relatively static anyway. It's not going to fragment anything. And that leads me into the last part that I wanted to talk about, and that is ext4 and XFS file fragmentation. Now, this applies only to folks who have spinning hard drives. If you have an SSD, then there is no need to ever defragment that drive. And you're probably saying, well, if I tried to do that, the system would say it's an SSD and I don't need to anyway. Guess what, gang? If you use SSH and you remote into a system, it doesn't catch that. And you can actually run the defrag program on an SSD. It won't hurt it, but it's totally unnecessary, one. And number two, it causes a lot of write cycles on your SSD because it's reorganizing all that data. So there's no need to do it. It makes no difference. So what did I write here? I said, do you need to defrag your drives? The answer is probably not. And the reason why is because the ext4 file system and XFS and many of the other file systems like JFS that you'll find available for Linux, they don't tend to fragment as they add data to the drive. As data is added and taken away, first of all, what ext4 does is that it looks for free space on the drive, and it also groups like files together. So back in the days of NTFS for Windows, if you go back long enough, you'll remember FAT16 and FAT32. All it did was just, if you sent data to the drive and you wanted it written, it found the first available space, it started writing. And if it ran into a used block of space on the drive, it would just pick up and it would just skip it and then go to the next available, and it would fragment itself. This is why NTFS, even to this day, defragments itself every week by default. It's usually set up in Windows to do that. So we in Linux, when they came up with the ext4 system, they were trying to work against that, mainly because you have servers that run unattended. They really can't be brought offline to defrag. They're too busy to defrag. So the file systems really need to be able to do it for themselves. Okay, so why would you ever want to defragment a Linux system? Well, there's a couple of reasons for that. If you have very large files, if you're working with virtual machines, if you are working with big audio and video files, and also if you're working with drives that are almost full, we're talking like more than 75% full, then what will happen is that you may actually get a little file fragmentation, because now ext4 or XFS can't find out, they're not finding the blocks of space it needs to put a whole file, so it's going to have to resort to fragmentation. With large files, they end up being a little bit fragmented anyway. It's just the way the system works. So you can defrag those if you want to. To check whether your drive needs to be defragmented, you can use the sudo e4 defrag program with the option C, that's just check, and then give it the path name or the device name to the drive. So let me show you how that works. So let's just jump down here to Ubuntu 16.04, because this is totally distro non-dependent. It makes no difference. It's distro agnostic, okay? So let's do it sudo, and we'll do e4 defrag, and then we'll give it the option C, and we won't leave an equal sign in there because that won't work. And we can either give it a device, or we can give it the actual folder that we want it to look at. In this case, we're just going to do it for the root partition, since everything is in root. And this has to be run with administrator privileges. So we'll just let that do that. And it's got to crunch for a little while. It's going through and it's going to read the entire file system table. It's going to go through every inode, and then it's going to go through the entire bitmap, everything, all the data table plus all the inodes. It's going to go through all that stuff. It's going to look at the journal. It's what it's doing right now, and to gather this information and to see the fragmentation level of the drive. So this actually does take a few seconds. Even on a really fast drive, this will take a few seconds, so we'll just be patient and wait. Actually, there we go. So it gives us a list of the fragmented files. And that kind of rendered funny, but here we go. So we've got the fragmented files. It says we got a few in here. That's to be expected. And then down here it gives us a total. It tells us what the average size of a data block is on this system. It's 32 kilobytes. That's called an extent. That's where ext4 comes from. It's an extended file system. And then the fragmentation score, in this case, is 0. And I bet you that if you've never done this on your Linux system and you're using ext4 and it's an average desktop where you do average things that people do with desktop computers, even if you've never done it and the machine has been up and running for 5 years, that score will be 0. That's how good ext4 is at doing that. So let's just run that command one more time. And we're going to do that this time with the device name. So you can do a whole device. Actually, a whole partition, as long as that partition is ext4. So how would you do that? Well, in this case, we've got SDA. That's the only ext4 partition we have available to us. So let's just do dev SDA. And now get a password in there. Oop. File system not mounted. Oh, that's my fault. See, I make mistakes too, gang. It's got to be SDA1. That's where it actually lives, right there. It's not. SDA is the drive. Now those are device names, and you can see those listed in your /dev folder on a Linux system near you. So it's actually just going to do the same thing. We don't have to sit around and wait for this to happen. It did a little faster over here. And we have a fragmentation score of 0, and the average size per extent is 41 kilobytes. So some useful information there. So there you go. So that's pretty much all you need to know about partitioning and fragmentation. I hope this helped. I hope that you got something out of the video. And I'm going to post these notes. And while you guys are watching, I am actually going to go ahead and fix that typo. Where is it? Where is it? Where is it? I'm going to find it. There it is. Right there. Let's put an A in there, because now it makes sense, and we'll save that file so before I do it, post it, you'll know what's going on. All right, gang. Thanks for watching. Love to hear your comments and suggestions. Please check out Easy Linux on Facebook, and if you do, give it a like. Check out Easy Linux on the web at easylinux.com. And also check out freedompenguin.com. I got an article that's going to be coming up there soon that ties in with the video I posted about podcasting not too long ago. And also, while I'm on the subject of Freedom Penguin, check out the new series of videos that Matt Hartley is going to be doing. I think they're really going to be interesting. He's going to throw a subject out to the community, get people's thoughts on it, and then comment on it. It's going to be pretty cool how he's going to do that. And Matt was on Brian Lunduke's Lunduke Hour show yesterday. So last night, while I was working on the computer here before I went to bed, I had that playing in the background and I was listening to him. And Matt gave me a big shout out on Brian's show there. So thank you, Matt. And thank you for Freedom Penguin. I do urge you to check that out. That's it, gang. Talk to you again soon.